Welcome, this is Professor Ridge and today's lesson 5.7, Inverses and Radical Functions. Our first learning objective is find the inverse of an invertible polynomial function. Finding the inverse of a polynomial function. So if you recall from chapter 3, we talked about inverses before, and just remember that two functions f and g are inverse functions if for every coordinate pair in f, AB, there exists a corresponding coordinate pair in the inverse function g, BA. So you're just going to switch the x and y. In other words, the coordinate pairs of inverse functions have the input and output interchanged. So you're just going to switch all the x and y's. Only one-to-one functions have inverses. And then if you recall that a one-to-one function has a unique output value for each input value and passes the horizontal line test. So again, the vertical line test to be a function, and then the horizontal line test to be a one-to-one function. Verifying two functions are inverses of one another. So two functions, f and g, are inverses of one and another if for all x in the domain of f and g, g of f of x is equal to f of g of x equals x. So basically, if we do the composition of g and f, they cancel each other out, and your input value will equal the output value of the composition. And if you switch the order, f composed with g, same thing, right? Those cancel out, and then your input value is equal to your output value. Okay, so example 1, verifying inverse functions show that f of x equals 1 over x plus 1 and f inverse of x equals 1 over x minus 1. Show those are inverse of each other for x not equal to 0 or negative 1. So basically for everything else. Okay, so again, your first, let's see, given a polynomial, find the inverse function by restricting the domain. Okay, we don't have to do this. What we need to do is we're going to verify their two functions. So we have to see that f, basically we're going to use this rule. So f inverse is the g and then f. So we're going to do both directions. Okay, so we got to verify both directions. So f inverse of x, I don't know what's going on. Oh, got my pen upside down. Okay, f inverse of x, we got to do both directions. We got to verify that both of these equal to x. Okay, so let's start with, it doesn't matter which one you start with. So if we do f inverse of x, well, f inverse of x is this. So we're going to take that expression and plug it inside this parenthesis, which means that we're going to take that expression and plug it into the f. So we take the x out, so this is f of x. We take this x out, and we're going to plug that into that function. So it'll be 1 over, we take the x out and put in f inverse, which is 1 over x minus 1, and then the plus 1. Okay, so f is the 1 over x plus 1, and then we're putting f inverse into f. So we put 1 over x minus 1 in place of the x in the f function. Now we're going to simplify this. We can drop the parentheses bottom since there's nothing in front of it, and there, no plus, no negative sign, no. It's actually, technically, there's a plus, but there's no times or anything. Okay, so we can drop those parentheses, and then the minus 1 plus 1 is 0. So we got 1 over x, which equals 1 times, and then the reciprocal 1 over x. Or you can view this as the reciprocal of 1 over x, which is just x. So either way, you got 1 times x over 1. X over 1 is just x. Okay, so that's this one. Now we got to show the other direction. F inverse of f of x Okay, so that is equal to, now we're going to go the other way. Let me see here. Let me erase all that. So now we're going to go the other way. We're going to take f of x, which is this one, and we're going to plug it into that function for x. So we're going to get f inverse. F of x is the 1 over the x plus 1. And then we're going to take this expression and plug it into f inverse, which is 1 over x. So we take the x out, minus 1. Again, we're going to take the x out and plug in what's inside the parentheses, 1 over x plus 1. All right, so this one's a little, well, actually, I was going to say let's get common denominators and add, but first let's simplify this. Remember, you can view this as the reciprocal of 1 over x plus 1, or, scratch work, I view this fraction bar as divided by, and the way you divide is you multiply by the reciprocal of the second one, so x plus 1 over 1. And then that's just going to get us x plus 1. Okay, so this part here, scratch work up there, it'd be x plus 1, x plus 1, and then we got the minus 1. The plus 1 minus 1 is 0, so we're just left with x. So now we have proved that f and f inverse are inverses of each other, because f of f inverse of x equals f inverse of f of x, and both of those were both equal to x. Okay, so that's our check. Okay, let's look at example 2 here, finding the inverse of a cubic function. So find the inverse of f of x is equal to 5x cubed plus 1. Okay, so the technique, we did this in chapter 3 again, but basically we're going to replace the f of x with the y. Oh yeah, they did it a little different in chapter 3, but this is the way I describe the way I do it. So we're going to replace the f of x with y, and then we're going to interchange the x's and y's. Okay, so that's 2 there. Then you're going to solve for the new y and rename it f inverse of x. So I want to get this y by itself, so subtract 1 from both sides. Divide by 5, both sides by 5. So now we got y cubed equals x minus 1 over 5, and then we're going to cube root both sides, and since this is an odd power, we don't have to worry about plus or minus or anything, which would give us a function that's not 1-to-1. So this gives us a 1-to-1 function. Oops, since it's cube root I mean. And then there's y. Now you're going to replace the y back to name it f inverse. And I'll just switch it. So f inverse of x is the cube root of x minus 1 over 5. And if you want to check, you can do what we just did in the last example and verify that when you compose f with f inverse, they cancel each other out and you end up with just x. So if you wanted to do a check, you got to do the composition. Technically, you're supposed to do both ways, but you know, if you're just checking real quick, you just do one way. It's used 99% of the time. It's going to be no problem. We're going to run into problem if the function's not 1-to-1. But anyway, so pretty much you just check one direction. You should be okay. But again, technically, you're supposed to check both f inverse f and then the other way around, f inverse. Okay, so If I want to check, then I'm going to plug one of the functions into the other one. So f is 5x cubed plus 1. And then I'm going to plug that into my f inverse. Take the x out, put in 5x cubed plus 1 right here. So then it's minus 1 over 5 inside the radical sign. So we got to simplify this first. So on the top we can drop the parentheses, the plus 1 minus 1 cancel. So we get 5x cubed over 5. I guess I should make that bigger. And then the 5's cancel. And then we get cube root of x cubed, which we know is just x. Okay, so that's our check. And then technically I need to do it the other way, but like I said, most time, 99% of the time, if it works one direction, it'll work the other. There's a couple oddball cases, right? And then if it's not one-to-one, that's where you can run into problems too. But we already checked that it was one-to-one. Okay, and looking at the graph, so the book posted this in example 2 for analysis. So if you look at f and f inverse, so f was the 5x cubed plus 1. So if you went on Desmos and graph, you would get this blue one. And notice that the y-intercept 0, 1. And then this point, if you put in 1 cubed is 1 times 5 is 5 plus 1 is 6. So you got this point here. And if you recall from 3.7, I believe, if I graph the inverse, it's going to be the mirror image or the reflection through the line y equals x. And you can see if I graph the red one is the inverse, and you can see how it's the mirror image. So if I got 0, 1 and I do the inverse, I switch the x and y, 1, 0, 1, 6, switch the x and y, 6, 1. And if this was on a piece of paper and I folded it on that line, y equals x, you can see that the blue and the red would match up each of the points. Okay, so I just wanted to point that out. Okay, moving on to the next learning objective, restrict the domain to find the inverse of a polynomial function. Okay, restricting the domain. If a function is not one-to-one, it cannot have an inverse. If we restrict the domain of the function so that it becomes one-to-one, thus creating a new function, this new function will have an inverse. So a classic example would be y equals, if f of x is x squared, right, you get this parabola, 0, 0, 1, 1, 2, 4, negative 1, negative 2, and we get this parabola. And it's not one-to-one because it would fail the vertical line, the horizontal line test. So if y equals, say, 2.2, we're going to get two x values that has that. So if I do the inverse, of that, now, it has an inverse relation, but the problem is if I flip this over the line y equals 1, it's going to look like this. Okay, so if I did 1, 1, negative 1, 1, I should have drew this a little better, but anyway, 4, 2, this one's not very good, but you get the general idea, right? So, and you can see this fails the vertical line test because here is x equals 4, and we get two y values, so it goes to y is 2 and negative 2, right? So that's not a function. So what we have to do is we're going to restrict the domain. So if I restrict the domain and just, let's say this red part is a separate function and get rid of that part, then when I flip this one over, okay, this would be the red one. So the red one is the inverse. The red ones are inverses of each other, and the black ones are inverses of each other. So I can restrict the domain and say, all right, let's let f of x be x squared provided x is greater than or equal to 0. And that's just going to be the right half of that parabola. And then this one function, this new function, is a one-to-one function, and the inverse is also a function. So the inverse function, f inverse of x, is going to be equal to square root of x, provided x is greater than 0. Okay? Greater than or equal to 0. All right? And then if I wanted the red one, then I would change the domain to be x is less than or equal to 0. And then the inverse would be f. Okay, so for the red one, let me just write it. I won't redraw it. So if I did f of x is x squared provided x is less than or equal to 0, that would be the red one. And then over here, f inverse of x would be the minus square root of x, which would be the bottom half of this parabola that's turned sideways. Okay, so it would just be the bottom half. Okay, so the technique then, given a polynomial function, restrict the domain of a function that is not one-to-one and then find the inverse. So first step, restrict the domain by determining a domain on which the original function is one-to-one. So you're going to create a new function where you're going to restrict the domain and it will become one-to-one, right? Then we're going to do the same thing if we have the equation, replace f of x with y, interchange the x and y, solve for your new y, and rename the function f inverse of x, and then revise the formula by ensuring the outputs of the inverse function correspond to the restricted domain of the original function. So remember, when you switch it, the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the inverse function. Okay, so you got to remember that. You're going to switch the x's and y's. All right. So again, if we think about this one. Okay, so this one, A, is basically just like the one I just did, but with the translation. This is your basic x squared function, this one, but shifted 4 units to the right. So this picture is going to be the same, but shifted to 4 units to the right. So again, we're going to have a problem with it's not one-to-one. So we're going to have to restrict the domain right at the vertex. So we're shifting it 4 units to the right. So that's why the domain is x is greater than or equal to 4. So we're going to have that parabola 1, 2, 3, 4. I'm going to give you a crude drawing here. And then 1. I guess I can make it nice. Okay, so again, we're restricting the domain x is greater than or equals 4, and that's where the vertex of the basic x squared function is going to be. So if you put in 4, 4 minus 4 is 0, 0 squared, 0. 5 minus 1 is 5 minus 4, sorry. 5 minus 4 is 1. 1 squared is 1. So we get the parabola, just the right side of it. And then if we put in 6, that would be 6 minus 4 is 2, and then 2 squared is 4. So remember how I said that the way I do it, I say, okay, this is shifting to the right 4 units. So I put my pretend origin at 4, 0. And then I pretend this is just y equals x squared. So 0 squared 0, 1 squared is 1, 2 squared is 4. But I count from the pretend origin. See? So 0, 0, 1, 1, 2, 4. So basically I'm just doing this picture, but I just move it 4 units to the right. And if you learned that idea, that makes graphing this super easy. Okay, that's parabola. So it should be something like that. Okay. And then we're going to, we didn't have to do the graph, I was just showing you that. It says restrict the domain, find the inverse. Okay, so it's already restricted for us. So we're going to switch the f of x to be y. The x is going to be, oh, we haven't switched anything yet. We're going to replace f of x with the y. So f of x becomes y. Now you interchange the x and y's. So x, y minus 4 squared. Then you're going to square both sides. So not square, you're going to square root both sides. Square root. And remember, you got to do the plus or minus, but remember we're doing just the positive one here. So we're going to throw out the negative one. So the y values are positive and you interchange, right? So y is greater than or equal to 0. So when you switch it, this is going to be your x's, and this will be, so x is positive, y is positive. So you can throw out the plus minus and just do the positive one. So the square root cancel each other. We get y minus 4. And then we add 4 to both sides. So that's going to be my f inverse. So f inverse of x is equal to square root of x plus 4. And then the domain for the inverse one will be the range of the original one. So the range is from 0 to infinity. So our domain is going to be x has to be greater than or equal to 0. Okay? And then the range is going to be this one. Y has to be greater than or equal to 4. Okay, and if you drew the inverse function, you're going to switch all these coordinates. So this would be 4, 0. So we do 0, 4. This is 5, 1. So we do 1, 5. This is 6, 4. So we do 4, 6. And basically that graph's going to look like that. And again, they didn't ask you to graph it. I just was kind of showing you. And if I put the line y equals x, oops, you would see they intersect on that line, both of these, and this will continue upward. So if I were to do this basically like that, and that one will continue like that. And those would be inverses of each other. So the red one's f inverse, black one is f. All right, B. Now we're going to do the other side. We're going to do the negative side. So for B, it's going to be the same work, but right here where we threw out the negative, we're going to keep the negative and throw out the positive. So we're going to get, let's see. So we're going to basically copy all that work. So we're going to switch the f of x to be just y, or replace it. Now we're going to switch the x and y's. And since I'm running that, I guess I can lift this. Okay. Now we're going to square root both sides. So square root. And then this would be plus or minus, but because we restricted the domain, we're going to throw out the plus one, and it's just going to be the minus one. Okay? And then so this value has to be negative, right? Because remember that the domain is x, and when we switch it, this x became a y. So y minus 4 has to be less than 0. So that's why this is a negative one. Hopefully that makes sense to you. And then we're going to add 4 to both sides. So negative square root of x is equal to, negative square root of x plus 4 is equal to y. And then our domain, so f inverse of x is equal to negative square root of x plus 4, and the domain is going to be, if we were to look at this picture, the domain will be the range. So basically it's the mirror image. We're doing this side. So the domain is from of the original functions x equals negative 4, not negative 4, x is less than 4, so that's going to become a range. Y is going to be less than or equal to 4. Now the range of the original function, again, is still going to be the positive integers, so the domain is just going to be x is greater than or equal to 0. Okay? So basically when I graph it, it would be down here. All right, here's the picture from the book, a little bit better than what I drew. So let's look at that. So for A, right, it was the x is greater than 4, so that's the solid blue one, right? And we did the inverse, it's the red one, okay? And you can see that those are mirror images through the line y equals x. And then when I did the B, it's now this solid portion, right? So that's the domain for f would be x is less than or equal to 4, and the range would be, this is for f, the range would be from 0 to infinity. So x is greater than or equal to 0. And so when I do f inverse, right, we're going to switch these. Oops, this should be y. So x becomes y, y becomes x. So the range, the domain is this range. So you switch that y to an x. X is greater than or equal to 0. And you can see that on the red one, the domain is x is greater than 0. And then the range, so the x becomes y, so it'll be y is less than or equal to 4. And you can see that the range is from negative infinity to 4, which is the same thing that I wrote here. So hopefully that makes a little more sense. If not, just keep at it, you'll figure it out. All right, let's go move on. All right, example 4, finding the inverse of a quadratic function when the restriction is not specified. So restrict the domain and then find the inverse. So again, here we got a quadratic, so we know it's going to be a parabola. Remember, if this is minus 2, that's shifted right 2, and this minus 3 out here is shifted down 3. So the way I think of it is I think of that as my pretend origin gets shifted to 2, negative 3. And then I'm just going to do, this is just a basic x squared parabola. So counting from here, I'm going to do 1, 1, 2, 4. So that's 3, and then 4 would be up 1. And then I have my mirror image. And you can see that it's not 1 to 1. My graph's really bad here, but anyway. So we got that parabola. So what we have to do, they didn't specify how we're going to restrict the domain. So if we want the inverse, depending on the situation, do we want to restrict the domain to be the right half of the parabola, or do we want the left half? So if we restrict it, so you can do it both ways, or you can do it one or the other, depending on the situation. So if I want the right half, I'm going to restrict the domain to be x is greater than or equal to 2. Okay, and then I proceed with my technique to get the inverse. So rewrite f of x as y. Now we're going to switch the x and y. So at this point, this is the inverse. Restricting it will make it a function, inverse function. So now I'm going to solve it for y. So add 3, square root both sides. So if I square root both sides, now this is where you got to decide which way you restricted it. So if you wanted the right side and you're restricting it, x is greater than 2, this is going to be the positive square root. If you wanted the left side, x is less than or equal to square root of 2, this would be negative square root. Okay, so when you flip it over, the right side would be, when I flip it over, the right side would be the top half and the left side would be the bottom half. Okay, so that's where you have to decide. Do you want the top one or the bottom one? So it would be a function. So if I do the right side, when I flip it over, that's going to be the top half. If I do the left side, that would be the bottom half. Okay, so that's what you got to decide. So if I did the right half, that would be positive. If I switch this to less than 2, that would be the negative one. Hopefully that makes sense. And then again, we want to get y by itself, so add 2 to both sides. Typically, you're going to put the plus 2 out in front. That way you don't confuse if it's under. You can write it behind, but just make sure that it's clear that it's not inside that square root symbol, right? That it's outside. So f inverse of x is 2 plus square root of x plus 3. And we're going to restrict. Now, remember, if you look at my graph here, this is the domain, and the range is going to be y is greater than or equal to negative 3. Okay, so this is going to become my domain. So x has to be greater than or equal to negative 3. And then my range is going to be y. So this is my domain. And my range is going to be y is greater than 2. Greater than or equal to 2. Okay, so you're switching the domain and range. And that'll give us the top half. Now if I wanted the bottom half, again this will switch to less than. That part will stay the same. And then right here this would be a minus square root. Okay, so if I did the bottom half, it would be 2 minus square root of x plus 3. And then my domain would be the same. X is greater than or equal to negative 3. But now my range would be y is less than or equal to 2. And that would be the bottom half. Okay? So that's how you have to pick one or the other depending on the situation. So if they don't specify it, you basically you have to decide which one you want and then specify that, and then you can pick which inverse function. In my calculus class, a lot of students get this wrong because they haven't really learned this. So there will be a question where you have to know which half are we talking about, the top half or the bottom half. You know, if the original function's the right side, that becomes the inverse becomes the top half. If the original function's the left side, the inverse is the bottom. Okay? All right, example 5. Find the inverse of a radical function. Restrict the domain of the function and then find the inverse. All right, so again, if you have a radical and it's an even power, the domain, you have to make the domain such that the denominator, not the radicand, the thing underneath the radical sign, has to be greater than or equal to 0. Okay, so that's going to be your domain. That's how you restrict it. So add 4, x is greater than or equal to 4. So our domain is from 4, if we want to write it interval notation. I haven't been doing that lately, but I should. Okay, so that's our domain. And then we want to find, and this is a one-to-one function, so it's just a translation of your basic square root function, 4 units to the right. So it's going to be that top half of that parabola. That's the square root function. So the range is going to be from 0 to infinity. So if I do the inverse function, it's the same technique. You're going to replace the f of x with y. Then you switch the x's and y's. So this becomes x. That one becomes y. Then you solve it. So you're going for, here they say solve for x. Restrict the domain. Okay, I like to just do like the same technique, so I'm not going to do it that way. I'm going to switch the x and y, and then I'm going to solve it for my new y. So I square both sides. The square and the square root cancel each other. So that cancels that. So we just get the y minus 4, and then add 4 to both sides. But we got to remember the domain for this one becomes the range for the inverse. So f inverse of x is x squared plus 4, but this function's not 1-to-1, so we got to restrict it. So we got to look at the domain and range of the original function. The domain was that one. The range is basically range is the y value. So it's x is greater than, not x, y. Y is greater than or equal to 0. It's from 0 to infinity. So for the inverse function, the domain and range switch. So the range is going to be, you switch, x becomes y, greater than or equal to 4. So that's going to be from 4 to infinity. And then the domain is the range of this original one. So that's going to be x greater than or equal to 0. So x can only be, you can only use x's that are greater than 0 in here. And the so again, interval notation 0 to infinity. Okay? So you have to look at the domain and range of the original function, and you're going to switch those for the domain and range for the inverse function. All right, example 6, solve an application with a cubic function. Park rangers construct a mound of gravel in the shape of a cone with the height equal to twice the radius. The volume of the cone in terms of radius is given by this formula. V equals 2/3 pi r cubed. Find the inverse of the function V equals 2/3 pi r cubed that determines the volume V of a cone and is a function of the radius r. Then use the inverse function to calculate the radius of such a mound of gravel measuring 100 cubic feet. Use pi equals 3.14. Okay, so basically we have this mound of gravel. It's a cone, r, and they said the height is equal to twice the radius, 2r. Okay, so the normal formula for volume of a cone is 1/3 pi r squared h, but since they told you h is 2r, that's what gives you the formula they gave you in the problem. 2/3 pi, this was r squared times r is r cubed. All right, so that's where this came from. So this is the generic formula for any cone. And then for this specific problem, it's going to be 2/3 pi r cubed. Find the inverse that determines the volume V. So since this is cubed, we don't have any problems with it being 1-to-1. And it is an application problem, so typically we're only concerned with r being greater than or equal to 0. And then the range is going to be greater than or equal to 0 as well, right? Because if you put it in a positive number, cube it's positive times positive number, so you're going to get any positive number. So as bigger R gets, the bigger the volume will get. So basically domain and range be that way. So now we're going to switch it. We want to find the inverse function. So let's solve this for, we're going to switch the V and the R. Or we're just going to solve it for R basically. So we want to write it. So let's see. We're going to multiply both sides by 2/3. Multiply by 3/2, sorry. So it's 3V over 2 equals pi R cubed. And then divide by pi. I'm just going to put it on the bottom here. That's dividing by pi. Dividing by pi is that. So the pi's cancel. We get R cubed. And then we cube root both sides. So cube root of 3V over 2 pi is equal to R. Cube root of R. Cube root of R cubed is R. Okay. So now we're writing R as a function of volume. So that would be the inverse function of volume as a function of R. Okay. So we're not going to switch the variables. We just rewrote it this way. For 2 pi, and we want to find, then use the inverse function, calculate the radius of the mound. So if we got 100 cubic feet of gravel, 100 cubic feet of gravel, pi 3.14, and then punch that in our calculator, and we're going to get 3.63. Okay, so the radius will be 3.63 feet. Example 7, finding the domain of a radical function composed with a rational function. So find the domain of the function. So we got the square root, that's the radical part. And inside the radical we have the rational function x plus 2 times x minus 3 over x minus 1. Okay, so it gets a little more complicated when you're doing this. So find the domain. So our first thing, if it was just a square root, we know that if we have a function like this, the radicand has to be greater than or equal to 0. That's going to be our domain. So we're going to start with that. So x plus 2 x minus 3 over x minus 1 has to be greater than or equal to 0. Okay, so now from intermediate algebra, there's a few different ways that this could be taught. So depending on how you learned before, so you got to think of think of these as individual numbers. So if we had a product of say two numbers divided by another number, if this was positive times a positive times a negative, that'd be a negative number. If we had a negative times a positive divided by a negative, that'd be a positive number. So this situation would be no good. This situation would be fine. So we got to analyze. So one of the methods we use is we analyze all the places where these numbers could be positive and negative. So if we look at each factor individually, x plus 2, it can change values. So this is what we call the sign graph method. So this is probably my favorite method other than looking at a graph. So I can graph this and then see where is it above the x-axis. Okay, so we're going to take each of these things and we're going to think about the number line. Okay, so where do each of these equal 0? So x equals 2 at x plus 2 equals 0 at -2. x minus 3 equals 0 at positive 3. We don't have to scale this. We just need to make sure it's the relative position. The smallest numbers on the left, the biggest numbers on the right, and the one that's in the middle is in the middle. So x minus 1 equals 0 at 1, so that would be in the middle here. And again, I don't need to scale this. I'm just making a chart. This is called the sign graph method. You can do, there's other methods where you can do test point method, but these are the values where the signs can change. So if I pick a number like x is negative 3 and I plug it into the expression, I'm going to get negative 3 plus 2, which is negative 1, and I don't care about the 1 part, I just care about the negative. So if we pick like x equals negative 3, negative 3 plus 2 is negative 1. So just care about the negative. Negative 3 minus 3 is negative. Negative 3 minus 1 is negative. And so our rational expression then is going to be, if x is any number between negative infinity and negative 2, it's going to be a negative times a negative divided by a negative, which will be a negative number. Okay? And then in the middle here, if say x is what's between 1 and negative 2, how about 0? So if x is 0, 0 plus 2 is positive, 0 minus 3 is negative, 0 minus 1 is also negative. And then we get a positive times a negative, positive times a negative divided by a negative. So we have a positive times a negative divided by a negative, which will get us positive. So any numbers between negative 2 and 1 will be greater than or equal to 0. And then we got to check here. So how about 2? So 2 plus 2 is positive. 2 minus 3 is negative. 2 minus 1 is positive. So a positive times a negative divided by a positive would be negative. And then here's the next interval from 3 to infinity. Let's see, if we picked x as 5. So 5 plus 2 is positive 7. 5 plus minus 3 is positive 2. 5 minus 1 is 4. So positive times a positive divided by a positive is positive. So if x is any number between, now, one more thing you got to consider, the denominator is not allowed to be 0, right? So this one has to be an open circle. The other 2 points can be closed circles. So our domain is going to be from negative 2 to 1. So any number between negative 2 and 1, not including 1, because it'll make the bottom undefined, or anything from 3 to infinity. 3 to infinity. Okay? So if you forgot how to analyze the sign of a rational function, that was a quick overview. There's a couple other ways you can do it. You can just do a straight test point, plug in a number, and calculate it. You can also look at the graph. So if you look at the graph, you just see what x values is the graph you want greater than 0, that's above the x-axis. Okay, and you can see it'll be in these two regions of the x-axis, from negative 2 to 1 and from 3 to infinity. Okay. Oh, and did you catch my mistake? This is a solid dot because we can be equal to 0, so that should be a include 3. This one is a parenthesis because the denominator can't be 0, so you got to exclude that extra one. Okay, example 8, finding the inverse of a rational function. The function c equals 20 plus 0.4n divided by 1 plus n represents the concentration C of an acid solution after n milliliters of 40% solution has been added to a 100 milliliter of a 20% solution. First, find the inverse of the function, that is, find an expression in terms of C. Then use your result to determine how much of 40% solution should be added. So the final mixture is 35% solution. So we want to rework this formula to be in terms of C instead of in terms of N. So we got C in terms of N. Okay, so what we do is we're going to cross multiply. So think of this way. So it'll be C times 100 plus N, and then 120 plus 0.4 N. Okay, let's distribute the C, so it'll be 100 C plus N times C. Get all the terms. We want to get N by itself, so we want all the N terms together on one side and everything else on the other side. So let's put the N's on this side and everything else on the other. So I'm going to subtract 100C, and I'm going to subtract 20, no, I wanted the N's on the other side. Subtract 0.4 N. So I have NC minus 0.4 N. So those cancel. And then I have 20, those cancel, minus 100C. Now, the technique then is I'm solving for N. So get all the N's on one side and then you factor the N out. See, both terms have N. That's the purpose, getting them all on one side. And then I can factor that out. And then think of this as just one number times N, and then you're going to divide both sides by that number. So then I'm going to divide by that number. Divide by that number. And now I have N by itself. Right, because that cancels, and I get N equals 20 minus 100C all over C minus 0.4. Okay, now use that result to determine how much of a 40% solution, so that's the concentration rate. N is the number of milliliters. So we want to put in 40, determine how much of a 40% solution should be added to get the final mixture that is 35%. Okay, so I'm a little, okay, N is the amount of 40% solution. So how much of the 40% solution N do we need to add to get a mixture that's concentration rate's 35? So C is the 35. So we're putting 35% in for C and solving it for N to figure out how much 40% solution to add to end up with the 35% solution. So we're going to put the 0.35 in here for C, 0.35 minus 0.4. So this C, that would be 20 minus 35. So this would be minus 0.05. So that will be, this would be negative 15. Negative, negative make positive, so that looks like 30, and then milliliters. So that's our answer. So we need to add 30 milliliters of the 40% solution to end up with the final mixture that's 35%. Oh, I guess I can't do my math here. So 15 divided by, I got to add 2 zeros. 2 zeros. So it'd be 300. Missed a decimal point there. Okay, so it's 300 milliliters that you need to add to end up with a 35% solution. And that looks like it brings us to the end of this lesson. So again, practice, practice, practice. Do as many of those exercises as you can. right? So minimum, do all the odds, and then if you can, do a few extra if you feel up to it. All right, I will see you next time.